Ladies and gentlemen, welcome to our webinar about XLink. Altogether, we have two webinars. It's about the product of IQ Wireless. This is webinar number 1. My name is Fana. I'm the moderator of this webinar, and in my real life, or let's say normal life, I'm a tech entrepreneur. I'm a consultant and trainer, and as a moderator, I always focus on cutting-edge technology. So I'm always interested in really the game-changing innovations, and I think we all would agree that satellites is the future of communication technology. So welcome to our seminar, our session. Yeah, it's a pleasure to be part of this discussion today. I have two top experts here, Andreas and Matthias. And yeah, beforehand, I would like to give you some information about the company we are talking about. It's IQ Wireless. It's based in Berlin. It's founded in 1999, and there are two product lines actually. One is focusing on satellite radio communication. This is the product we are talking about today. It's IQ spacecom with the product XLink. And then there's also a second product line. It's early wildfire detection system, and we will come back to that later on maybe. Yeah, I had the pleasure to visit your company. Thank you very much again, for your warm welcome there. I've seen all the laboratories, and I have to say that I'm very much impressed about all your systems and technologies. And there are over 30 experts working kind of all around the clock and developing new systems in the field of satellite technology. So I'm glad to talk to you. On the right hand, you see Matthias Reibe. He's the head of engineering. He's the CTO of the whole spacecom sector. And Andreas, he's one of our top engineers responsible for research and development and a true space expert. Hi, Andreas. Hi, Matthias.
Hi.
Hi.
Hello. Yeah, a warm welcome from our side here in Berlin, from Matthias and me. We are glad to give you this presentation within this webinar, and yeah, we're also looking forward to this webinar, the discussion afterwards.
Hello and welcome from my side too.
Thank you, Matthias. Thank you, Andreas. Yeah, let's dive into space technology right away. During my company visit in Berlin, I did some research about the ecosystem there. So I discovered there are many companies and startups being in the satellite industry. So that was very impressive, and that was also new to me. So how are you embedded into this ecosystem?
Here in Berlin, actually, we are the only ones who are focusing on this radio communication satellite. But within this ecosystem, we know a lot of the other companies, and in collaboration with them, I think here in Berlin, we can provide full small satellite solution where we can provide this radio communication solution to users.
Mm-hmm. And where does it all come from? Why do you actually focus on satellite communication? What's so interesting about it for you?
Yeah, I think this satellite communication, this radio communication is a very important field for the satellite. So every satellite has a radio communication system integrated. Yeah, let's say without the radio communications, the satellites are useless. And with the background of this IQ Wireless company, that means the IQ Wireless developed a small and reliable radio communication system since 20 years ago. And so it's consequent for us now to go to the field of satellite communication, small satellite communication.
Okay, this sounds very promising. Yeah, we all know that the satellites are quite small we're talking about. So how do you manage?
Yeah, within the small satellite, it's of course all the budgets are very constrained. So we have a very limited volume, very little limited power budget and mass budget, and so we have to keep it all very small. That's very important. Mm-hmm. And yeah, that's of course challenging, but yeah, with our experience, we have a solution for that, and can provide it to users and operators.
Yes, and for instance, there are challenges also for the radio communication, depend on the distances you have. please think about your cell phones. There you have distances of maximum some kilometers between your cell phone and a base station. But in satellite communication, you will have 100,000 or 10,000 of kilometers distance you have to cover with your radio equipment.
Yeah, and regarding this, the radio communication, there are more impairments like the atmosphere and the Doppler effects due to the movement of the satellites. And yeah, that's the idea. Here we have depict the figure of the frequency bands available for satellite communication. Here we use, for the satellite communication field, we use the IEEE names for the satellite bands in the middle. And traditionally, these radio communications for the small sat is using the VHF and the UHF band. There are amateur radio bands available which are easily accessible for users without that much regulation and with reliable hardware available. But the bandwidth is very small and limited there. And I have to, or you have to note that this figure is logarithmic scaled over the frequency. That means the higher bands, for example, the X band is much wider than the VHF band, and we are focusing on the bands which are marked, let's say the S up to the Ka bands. This is these are the frequency bands we are focusing on for the payload data communication.
But you have to keep in mind that not the whole bands are available for satellite communication. There are only some small subbands available for satellite communication.
Yeah, no one can use the whole band. So these are only small ranges of, let's say, some kilohertz up to some megahertz and more available.
Maybe you should quickly explain how is the procedure to get such a band. Is there the regulations on this?
Yeah, of course, because the frequency spectrum is a shared resource, and yeah, you have, everybody has to take care that that no one is disturbing the other using the same frequency at the same time at the same place. So that's why these frequency bands or frequency ranges are regulated on an international level, and yeah, the users have to know that requesting this frequency and get a license for using frequency, this is a very long process and needs also some effort. It's not that easy, but yeah, the users have to know this.
Yeah, I think the audience knows a lot about regulation. Also, this is like a issue. You can talk like for hours. Yeah.
Yeah, so, yeah, maybe topic of a forthcoming webinar.
Yeah, we will do that definitely. Okay. And yeah, why do you focus especially on these radio frequencies?
Because we are focusing on the payload data rate communication. Let's say also in downlink we need this large data rates, and these large data rates requires large bandwidth. There is a physical connection between this resources, and these large bandwidth are available only in higher frequency band. As I mentioned before, these higher frequency bands are much wider. And yeah, we found a solution, or we developed a solution for that within system and a platform which provides a very efficient way to yeah, transmit or receive these high data rates over this limited amount of bandwidth. So this is what we introducing this, or where we introduce this XLink unit. We see here a sample picture which has, yeah, this bandwidth with up to 56 megahertz, and very good way to use the bandwidth.
Okay. During my company visit, you mentioned that XLink is a multifunctional platform. So maybe you could tell us more about it.
Yeah, we call it a platform because it's a very flexible system. So on this platform, there's a basic system always available, like in any other communication system. We have the RF interfaces, the interfaces to the satellite with the standard protocols, and which results in a standard data rate available to the user. And this can be extended by more hardware systems and more software systems. So, for example, we can use the different power supplies. We can use different software stacks. We can use different RF systems, front ends available. So we have multiple channels for transmitting, for receiving. We can combine the two. We can set it to different frequency bands. We can extend it to the higher frequency bands. We can implement different protocols. We have different data interfaces available, which are always adjustable and customizable. And this, in the end, results in the different data rates we can provide to the customer. So up to 100 megabit per second. In this small unit, I think the size is not given here, but
I will explain it tomorrow.
Yeah. And let's say it has a size it will fit in a hand. So it's very small and fit in a CubeSat. But I think Matthias will talk about this.
Wow, like this, yeah, this is really astounding, I have to say. So we really can say that XLink is much more than a radio transceiver. It's a fully integrated and really flexible platform, right?
Yeah, additionally, we call it a software-defined radio. So software-defined radio, that's the term for systems which are fully controllable by software and configurable by software. That means with the different hardware possibilities, which are always integrated in this system or in this platform, and also the different software options, different protocols, we can adjust it and by software only. That's the reason.
Mm-hmm.
But it's not only a software-defined radio. Andreas explained it already. We have the full RF front-end integrated in our device too.
Yeah.
So you have the direct connection. You can see here, and as we explain it to you, to the antenna without any additional LNA or power amplifier.
Yeah. I will get later to the point directly. Here you have you can see maybe a simplified picture of a satellite system. So with the different subsystem blocks, and with this communication system, this has all the required interfaces to the antenna, from the power supply, and the data interfaces to onboard computer or payload, where which one is requiring the data communication. And I can go into some details of the RF front end Matthias mentioned. So all the required building blocks of an RF front end. So the LNA, the mixers, filters, oscillators are integrated into this small system in a very efficient way and multiple times for different frequency bands, for example, at different channels. So we have the possibility to combine two channels, provide these channels in different frequency bands, and we are free to extend the front ends, possibly by some external hardware. This is very free and flexible, but let's say normally within this SC and X band, this is for a direct connection to the antenna.
Mm-hmm.
And to give the other interface, for example, the power supply interface, I already mentioned, is we provide some hardware options for this, the low voltage option and the high voltage option up to 50 volts, and this is suitable for any small set platform we know. So that means this will fit into any platform and is compatible. And what we are also proud of is that this solution has a very low power consumption. So we are in standard configuration below 10 watts, which is very outstanding.
Yes. Yes. So you, with a 10 watt in standard configuration, I assume your customers might be interested in the power consumption of different XLink configurations also, since power consumption, of course, is a very important factor. So maybe would you give us some more information about the power consumption in different XLink configurations?
Yeah, power consumption is, of course, very important because it's a limited resource, and the exact power consumption is up to the configuration. So as I introduced, there are several hardware options integrated and software options integrated, and which one is enabled or used, and this results in different power consumption. Let's give you some detailed example. If you use only the receiver, the system is around 3 watt power consumption, and but with the full system enabled, let's say the receiver is enabled and 2 transmitters are enabled, we are always or already below 15 watts, which is very low for this system or for such a system.
And all this correspond to different operation modes we have implemented as modes in our system: receive mode, transmit mode, and other points. And these modes you can adjust on board, on the fly, on from your onboard computer side to configure this your system on board.
Yeah, you can use such a system in the satellite for various different applications with different options enabled and in different operating modes. And, let's say something about the interface to the onboard computer or the payload. So for the data interface, not only the payload data, also the TMTC, the telemetry and telecommand interface. Here we are implemented this Ethernet interface. Ethernet is for us the future trend for this communication interface, because it's widely available in hardware or the embedded processor platforms, for example, which are also used in small satellite onboard computers, have integrated Ethernet integrated into the chips. And there are all the software stacks available, software protocols are available, they are widely used and easy to use, and we can provide this as a gigabit Ethernet. With the gigabit Ethernet can provide also this high data rates, and so we think that this is a very good thing for the users. And yeah, but also we have the traditional common satellite interfaces as hardware options integrated, so SPI, UART, and what is common in satellite communication.
But on the other hand, you must also use very powerful transmission algorithm in the air interface, modulation algorithm, forward error correction algorithm to transmit these high data rates from your device.
Yeah. This comes to the implementation of the protocols from the Ethernet interface to the RF. So let's give a short talk about this implementation of this communications techniques. We have to map the data, the bits, into the symbols on the radio link, and there are some standard ways to do this, which are standardized. We have implemented the standards. Additionally, they have to implement or have to use some error correction techniques. We have also implemented this. We have implemented the standards and also some improved coding and modulation techniques. and we can support this various standards and also proprietary standards for this application. Actually, we can provide data links and downlink up to 100 megabit with this, and this with a very efficient usage of the bandwidth we are only allowed to use this. And this is also very high level technique and protocols.
And that's also a benefit of our SDR platform, that we can adjust on the fly modulation type, forward error correction type, and so on. So you can implement algorithms like ACM, like adaptive coding and modulation modes, to maximize your data rate you can achieve on the communication channel.
Yes.
Mm-hmm. Okay, this is very exciting. Yeah, you have more information about protocols?
Yeah. As I already mentioned, so there are standard protocols. So I think there's a CCSDS organization which provides a standard framework for a lot of, let's say, all of applications for satellites, with the coding modulation standards and more, which is compatible to the traditional OSI layer communication. And we have implemented this standard protocols. Here we can see some examples. Only this standard protocols useful for small satellites, of course, not any of the CCSDS. But we are going on, and what we have done, we have tested this with a lot of commercially available ground modems and ground stations. So we are very proud to say that we can assure that we are compatible to all of the ground modems available, maybe already available at customer sites, or if they want to use some open ground stations or commercial ground stations, we can assure that we are compatible with it. We are verified by tests.
Okay, it's absolutely fascinating to learning about your how powerful and multifunctional platform, I have to say. So as I understood it so far, you're adding more and more features to your platform. So you have more in the pipeline. What are your plans?
Yeah, plan is always to improve the development. So this platform has resources for new technologies, new protocols. That means we're always improving this implementation. And we have ideas for new applications and for new techniques. Maybe some users or people from the community have said ideas we are willing to implement and to test. So and because of this flexible platform, we are able to adapt all the interfaces, protocols to the user requirements or user ideas, also the mechanics. And yeah, the idea is, or the motivation is, to provide a full radio communication solution to the users or to the satellite small sat community, to have an easy solution for data handling between ground and satellite, and yeah, vice versa.
But I must say, or I must add, the most of the ideas come from the customers, but we are able to implement these ideas and to find a solution for them.
Yeah, so you're really working together with the customers. And yeah, what I've learned today also is like that XLink is a very flexible and really multifunctional platform, which I find quite impressive. Multi-frequencies are possible. And I also learned about the power consumption, which is very, very efficient, which is like one of the most important factors, of course, the endurance. And also you're able to adapt the flexible platform to the needs of the customer. So you're really developing projects together with the customers, and you make the customer successful, actually. Yeah. So yeah, this is really amazing. And yeah, I'm a little bit sad that the session is nearly over now.
Let's show it. Let's show this on a slide. So I think we have prepared a figure with summarize all the key facts from this platform or of this platform. As you already said, this provides a very customized solution to the user, up to his needs, requirements, his ideas. We can fulfill this or implement this, customize this on this unified SDR platform. I talked about the different frequency bands. We are able to providing this radio communication on it. This is very easy and customizable. And yeah, I can also now say that this is a very cost-efficient or cost-effective solution with a very short delivery time. I think in the second webinar, Matthias will talk about more about this facts. This has to do something also with the manufacturing and the integration of the system. What I want to say now to the audience and the community that this is already available platform and product, and so we can provide you a short delivery time, and yeah, it's already on the market and available. So so feel free to ask us for or present us ideas, and I think, or I'm sure that we find this communication solutions.
Yes, and I will underline tomorrow in the webinar how we can come to this cost-effective solution. What is our way to come to this result, especially on the cost side and also on the delivering time side.
Yeah, I'm already very excited about the second webinar. For the audience, please take the chance and contact Andreas and Matthias. They are very much looking forward answering all your questions. As Matthias and Andreas said, they are also like developing the products together with you. So it's not just like delivering something, it's really like also kind of consultancy advice, and it's really doing a project together. So I think this is like the way it should be. And yeah, see you in the second webinar. Go to the website iqspacecom.com. And yeah, thank you very much for participating into that webinar, and see you in the second webinar maybe.
Thank you, Fenna.
Yeah, thank you, Fenna. Thank you, audience. Feel free to contact us.